Rare Earth Hypothesis. The rare Earth hypothesis presents an intriguing perspective on why humanity has not yet discovered other intelligent life in the vast expanse of the cosmos. First detailed comprehensively by paleontologist Peter Ward and astronomer Donald Brownlee in their influential 2000 book, Rare Earth: Why Complex Life is Uncommon in the Universe. This theory argues that the conditions required for a planet to support complex, intelligent life are incredibly specific, making Earth extraordinarily rare, perhaps even unique in the universe. Earth's favorable position begins with its location within the Milky Way galaxy, often described as the galactic habitable zone. Positioned neither too close nor too far from the densely packed center of the galaxy, Earth avoids catastrophic cosmic events such as supernova explosions and gamma-ray bursts that frequently sterilize regions closer to the core. Simultaneously, being sufficiently near the galaxy's center allows Earth to benefit from the heavier elements essential for life, including carbon, nitrogen, oxygen, and iron, elements formed within stars and dispersed throughout space by stellar explosions. Thus, Earth occupies an ideal position within the galaxy, carefully balanced between these extremes. Beyond galactic positioning, Earth's orbit around the Sun is another finely tuned detail critical for sustaining complex life. Our planet circles a remarkably stable, medium-sized star, a G-type star known commonly as our Sun. Unlike massive stars, which burn brightly but briefly before violently exploding, or smaller, less predictable stars prone to powerful flares, the Sun provides a consistent and stable source of energy. This stability ensures Earth's climate remains conducive to life's long-term development and evolution over billions of years. A significant factor contributing to Earth's habitability is the presence of its large moon, unusual for a planet of Earth's size. The gravitational pull of the moon stabilizes Earth's axial tilt, minimizing severe fluctuations in climate conditions that would otherwise occur. Without this stabilizing influence, Earth would experience chaotic and extreme weather patterns, hindering the slow and delicate evolutionary processes necessary for complex organisms to emerge and thrive. Moreover, Earth's geology plays an essential role in its capacity to support life. Active plate tectonics continuously reshape the planet's surface, recycling nutrients vital to ecosystems and regulating atmospheric gases. This geological dynamism maintains Earth's environment within a range suitable for diverse life forms, preventing catastrophic events like runaway greenhouse effects that could otherwise render the planet uninhabitable. Earth's ongoing geological activity also contributes to the magnetic field generation, another critical element in maintaining life. Earth's internal structure significantly contributes to its habitability through the generation of a powerful magnetic field. Originating from the motion of molten iron in Earth's core, this magnetic shield protects the planet from harmful cosmic radiation and solar winds that could otherwise strip away the atmosphere. Mars, lacking such a protective magnetic shield, illustrates how critical this defense is for preserving conditions favorable to life. Additionally, Earth's size and composition contribute significantly to its habitability. Our planet is ideally sized to retain an atmosphere rich enough to sustain life, yet manageable enough to avoid excessive atmospheric pressure that would make the surface unlivable. The combination of rocky terrain and abundant water further enhances the planet's suitability for life, providing the necessary environment for complex chemical interactions essential to biology. The presence and abundance of water itself represent yet another crucial component in Earth's exceptional habitability. Liquid water is unique in its ability to facilitate the chemical reactions fundamental to life. Earth's oceans serve as enormous reservoirs, regulating temperatures, distributing nutrients, and hosting countless ecosystems, all of which have contributed significantly to biological diversity and complexity. Earth's water cycle, maintained by a delicate balance of solar radiation, gravity, and atmospheric conditions, further demonstrates the exceptional circumstances that have supported life for billions of years. Finally, Earth's remarkable longevity and environmental stability over geological timescales have allowed life not merely to emerge, but also to evolve progressively into increasingly complex forms. Despite periodic disruptions, such as volcanic eruptions, asteroid impacts, ice ages, and climate fluctuations, Earth has managed to maintain relatively stable conditions conducive to the slow evolution of intelligent beings capable of reflecting on their existence and exploring their surroundings. Peter Ward and Donald Brownlee's original work goes beyond mere astrophysical observations, integrating interdisciplinary insights from paleontology, geology, astronomy, and biology. Their synthesis of diverse scientific knowledge provides a powerful, comprehensive framework for understanding the unique conditions necessary for complex life. Ward and Brownlee also engage deeply with evolutionary biology, emphasizing the fragile and contingent nature of life's progression on Earth, underscoring just how rare such conditions might be across the cosmos. Taken together, these precisely calibrated factors suggest that Earth's conditions for supporting complex life are exceptionally rare, perhaps unique. The rare Earth hypothesis argues that, while simple microbial life may be abundant throughout the universe, the precise convergence of factors enabling intelligent, complex life is astonishingly scarce. If true, this hypothesis profoundly reshapes our understanding of humanity's place in the cosmos, underscoring the extraordinary nature of our home planet. In contemplating the implications of Earth's uniqueness, the rare Earth hypothesis urges humanity toward greater responsibility and stewardship. Recognizing Earth's potential singularity in supporting intelligent life intensifies our obligation to protect and sustain this fragile, remarkable planet. It serves as a powerful reminder that in the immense cosmic expanse, Earth may stand alone, a beacon of life and complexity against the vast emptiness. Thus, the rare Earth hypothesis not only offers a compelling explanation for humanity's solitude amidst the stars, but also instills a profound sense of wonder, humility, and duty toward the preservation of our extraordinary world. In recognizing our rare fortune, we gain greater insight into the deep interconnectedness of Earth's systems and the delicate balance of conditions that have nurtured life, enhancing our appreciation for the cosmic rarity of our home. Great Filter Hypothesis. The Great Filter Hypothesis is a compelling and thought-provoking concept introduced to address one of humanity's most profound mysteries. Why, despite the vast expanse and seemingly endless potential for life throughout the universe, have humans not yet encountered other intelligent civilizations? Coined and extensively discussed by economist Robin Hanson in 1998, this hypothesis posits that there are critical barriers or filters within the evolutionary path of life that dramatically reduce the likelihood of intelligent civilizations emerging or surviving long enough to engage in interstellar communication or exploration. At the core of this hypothesis lies a sobering idea that the universe might indeed be teeming with life in its simplest forms, yet complex, intelligent life could be extraordinarily scarce due to significant, perhaps insurmountable challenges along evolutionary and technological timelines. These barriers, or filters, are events or stages in evolutionary development that are exceptionally difficult or unlikely for life to successfully navigate. The Great Filter could theoretically exist at various points along the developmental path of life, beginning with the most fundamental steps. Initially, life must originate from non-living matter, a process known as abiogenesis. Despite substantial research, scientists still struggle to fully comprehend this transition from chemistry to biology. This initial hurdle alone could represent a formidable filter, suggesting that the spontaneous emergence of life from non-life may be exceedingly rare, making Earth one of few, perhaps the only places where this has occurred. If life does manage to surpass this initial barrier, it faces additional evolutionary hurdles. The transition from simple single-celled organisms to more complex multicellular life forms could represent another profound filter. On Earth, billions of years passed before organisms evolved into multicellular beings. This incredibly slow, challenging progression hints at the extraordinary difficulty of achieving biological complexity, potentially making this evolutionary step another critical barrier, significantly reducing the universe's abundance of complex life. Even after overcoming these biological filters, life must evolve intelligence, which itself may be exceptionally improbable. Intelligence requires not just survival mechanisms, but also a combination of environmental conditions, ecological pressures, and evolutionary incentives to favor cognitive sophistication. The mere existence of intelligence as seen in humans may thus be a rare evolutionary accident, not an inevitable consequence of life's complexity. Furthermore, the great filter might also be technological. It could be that intelligent civilizations frequently destroy themselves before achieving interstellar communication or travel capabilities. The rapid advancement of technology carries inherent risks: nuclear warfare, catastrophic environmental damage, global pandemics, or artificial intelligence accidents that might serve as a filter preventing civilizations from surviving long enough to explore or communicate beyond their home planets. The chilling implication of this possibility is that humanity may yet face its own great filter. Our species has achieved tremendous technological progress in an astonishingly short time frame, but these advancements come with potentially existential threats. Nuclear proliferation, climate change, biological warfare, and advanced artificial intelligence could all represent barriers that humanity must navigate successfully to avoid becoming another civilization extinguished prematurely in the cosmic timeline. Alternatively, it is also possible that humanity has already passed the great filter and it lies behind us. Perhaps the emergence of intelligent life itself, human beings capable of creating advanced civilizations and sophisticated technology, was the improbable leap, a cosmic miracle that few, if any, other species have achieved. If true, this would imply that humanity occupies an incredibly rare and privileged position in the universe, having overcome odds stacked significantly against such advanced development. This uncertainty of where the great filter resides, in our past or future, gives the hypothesis its emotional resonance and existential weight. If the filter lies ahead, humanity faces immense responsibility to avoid self-destruction, requiring unprecedented levels of global cooperation, foresight, and stewardship. Conversely, if the filter lies behind us, our rarity underscores the importance of preserving and nurturing the delicate balance of conditions that allowed our species to emerge and thrive. The great filter hypothesis thus offers more than a scientific explanation. It serves as a powerful existential mirror, reflecting humanity's vulnerabilities, strengths, and ultimate responsibilities. It suggests that the silence of the cosmos might not just be an indication of cosmic emptiness, but a sobering reminder of the immense challenges intelligent life faces in surviving and thriving. In contemplating the great filter, we are forced to reflect deeply on our actions, values, and priorities as a species. It compels humanity to confront difficult questions about the sustainability of our civilization, our ethical responsibility towards future generations, and the broader cosmic implications of our choices. Regardless of where this filter lies, the great filter hypothesis underscores the profound and fragile nature of intelligent existence and the extraordinary significance of humanity's journey amidst the silent, mysterious expanse of the universe. Zoo hypothesis. The zoo hypothesis offers a fascinating explanation for the silence humanity experiences in its quest to detect intelligent extraterrestrial life. This intriguing theory suggests that highly advanced extraterrestrial civilizations do exist and are fully aware of humanity's presence. However, they deliberately avoid interacting or communicating with humans. Instead, they observe us quietly and unobtrusively, much as humans might carefully study animals in a protected wildlife sanctuary or zoo, hence the name. First proposed by astronomer John Ball in 1973, the zoo hypothesis offers a thoughtful resolution to the famous Fermi paradox, the question posed by physicist Enrico Fermi, who famously asked, "Where is everybody?" Given the enormous number of potentially habitable planets scattered throughout the galaxy, it seems paradoxical that humanity has not yet encountered or even detected clear signals from intelligent alien civilizations. According to the zoo hypothesis, extraterrestrial societies may intentionally maintain distance from Earth to allow human civilization to develop naturally without external influence or interference. These advanced civilizations may adhere to strict ethical guidelines or a collective agreement to protect emerging civilizations from premature or disruptive interactions. This concept mirrors the notion of the prime directive, popularized by science fiction series like Star Trek, wherein more developed civilizations abstain from interfering with less technologically advanced species to ensure their independent cultural and technological evolution. In this context, Earth would function similarly to a carefully curated natural reserve, where humanity is free to evolve culturally, technologically, and ethically, guided only by internal dynamics and natural environmental pressures. The observing civilizations might believe that intervening prematurely could significantly disrupt humanity's natural development, either by causing cultural shock, technological dependency, or potential societal collapse. Thus, they choose deliberate invisibility, observing humanity silently, patiently, and respectfully from afar. Supporters of the zoo hypothesis argue that this scenario would explain why humans have detected no definitive signals from extraterrestrial beings despite decades of searching. Advanced alien civilizations, capable of interstellar travel or long-distance communication, could undoubtedly mask their presence and signals effectively, leaving no evidence of their existence detectable by current human technologies. These observers may even establish careful boundaries or exclusion zones, avoiding transmitting signals directly towards Earth or disguising any transmissions in ways indistinguishable from natural cosmic noise. This theory raises intriguing questions about humanity's maturity and readiness for contact. The zoo hypothesis implies that extraterrestrial civilizations might closely monitor human progress, awaiting a significant benchmark or developmental milestone before revealing themselves. Such milestones could include sustainable global peace, the responsible use of technology, or the achievement of interstellar travel, signaling humanity's readiness to join a broader cosmic community. This notion is both comforting and unsettling. On the one hand, it offers the possibility that humanity is not alone in the universe, and is, in fact, under benevolent observation by more advanced civilizations. It suggests the existence of a universal ethical principle of non-interference, reflecting a deep respect for diversity and autonomy among intelligent beings. On the other hand, it introduces a sense of vulnerability, highlighting humanity's relative immaturity and dependence on unseen external judgments about our readiness to join the cosmic stage. Critics of the zoo hypothesis often point out its inherent speculative nature, emphasizing that such scenarios lack empirical support and rely heavily on assumptions about alien psychology, ethics, and technological capabilities. Critics argue that the hypothesis anthropomorphizes extraterrestrial motivations, attributing to alien civilizations human-like values and reasoning without substantial evidence. Additionally, they argue that maintaining an absolute cloak of invisibility or silence over millions or billions of years would be exceedingly difficult, even for highly advanced species, due to potential internal disagreements, accidental signal leakage, or technological malfunctions. Despite these criticisms, the zoo hypothesis remains a compelling and popular explanation for the Fermi paradox, capturing public imagination and inspiring ongoing debates about the nature of intelligence, ethics, and interstellar relations. It resonates profoundly with humanity's own ethical debates regarding our interactions with less developed cultures and species, reflecting a deeper philosophical introspection about our responsibility towards other forms of life and our place within a larger cosmic hierarchy. Moreover, the hypothesis carries significant philosophical implications for humanity's perception of itself and its future. If humanity is indeed under careful observation, our civilization's actions and choices gain greater cosmic significance. The zoo hypothesis implicitly challenges humanity to evolve responsibly, ethically, and sustainably, suggesting that only by demonstrating maturity, wisdom, and compassion might we someday earn the privilege of participating openly in an interstellar community. Ultimately, The zoo hypothesis invites humanity to reflect deeply on our collective behavior, technological advancement, and ethical development. It suggests that perhaps our isolation is neither random nor permanent, but purposeful and temporary, dependent upon our continued growth and evolution as a species. In embracing this perspective, humanity may find a profound sense of hope and purpose, guided by the potential of a future in which we earn our place within a broader cosmic community, no longer merely observed but fully welcomed as active participants in the rich tapestry of intelligent life across the universe. Prime Directive, non-interference hypothesis. The Prime Directive, also known as the non-interference hypothesis, offers an intriguing explanation for the cosmic silence humans experience despite extensive efforts to detect extraterrestrial intelligence. Rooted deeply in philosophical and ethical considerations, this hypothesis suggests that advanced extraterrestrial civilizations consciously avoid contact with less developed societies, following strict principles of non-intervention to ensure those societies can evolve independently and organically. The concept became widely known and popularized through science fiction, particularly by the iconic television series Star Trek, where the Prime Directive is portrayed as a fundamental guiding principle. However, in reality, this idea has profound implications in addressing one of humanity's greatest cosmic mysteries, the Fermi paradox, which questions why, despite billions of potentially habitable planets, humanity has not yet encountered or detected signs of other intelligent civilizations. According to this hypothesis, extraterrestrial civilizations may deliberately remain hidden from humanity, maintaining a careful distance to allow human society to mature at its natural pace, without external influence. The principle behind such a directive emphasizes respect for autonomy and acknowledges that interference could profoundly disrupt or alter the natural evolution of societies, possibly with detrimental consequences. Proponents of the Prime Directive suggest that advanced extraterrestrial species might possess both the technological capability and ethical sophistication necessary to enforce strict non-interference protocols. Their deliberate invisibility might be motivated by historical experiences, ethical consensus, or long-term strategic foresight. Perhaps these civilizations have observed or learned from past mistakes, realizing the damaging impacts that premature exposure or technological dependence can have on less developed societies. Under such a hypothesis, Earth would resemble a carefully guarded nature reserve, quietly observed but never directly contacted by civilizations that have evolved past internal conflict and recklessness. Humanity, in this scenario, is allowed to progress undisturbed, facing and overcoming its challenges independently. The silent observers might believe that true societal maturity and sustainable advancement can only be achieved through self-discovery, autonomous growth, and independent problem-solving. One compelling aspect of this hypothesis is the implicit belief that there exists a universal standard of ethical behavior among intelligent civilizations, a collective understanding or agreement on non-interference. This suggests an interstellar community bound by shared moral values, mutual respect, and a profound commitment to allowing emerging societies to reach critical developmental milestones independently. The Prime Directive scenario resonates deeply with humanity's own historical experiences, drawing analogies to Earth's interactions between technologically advanced societies and indigenous populations. Throughout human history, interactions characterized by interference have often resulted in cultural disruption, loss of autonomy, exploitation, and even extinction of less developed cultures. Reflecting on this history, humans can readily grasp the ethical rationale behind such a non-interference approach, imagining that an enlightened extraterrestrial civilization would consciously seek to avoid repeating similar mistakes. Despite its appeal, the Prime Directive hypothesis also faces criticism, primarily based on its speculative nature. Critics argue that attributing human-like ethical considerations and motivations to alien civilizations could be inherently flawed, given the profound uncertainties regarding alien psychology, social structures, and moral frameworks. There's also the practical argument that total and consistent adherence to non-interference across many civilizations over vast timescales might be challenging or improbable, especially considering the diversity and unpredictability of intelligent life. Yet, advocates of the hypothesis counter that any civilization advanced enough to traverse the stars would likely have developed sophisticated societal controls and ethical frameworks necessary to maintain discipline and adherence to such principles. These advanced societies could possess surveillance technologies sophisticated enough to monitor emerging civilizations without detection, carefully managing their interactions to ensure strict compliance with their ethical standards. The implications of the prime directive hypothesis for humanity are significant, providing both reassurance and responsibility. On one hand, it offers comfort in the possibility that we are not alone in the universe and may someday be welcomed into a broader, ethically mature interstellar community. On the other hand, it emphasizes our species' responsibility to mature ethically, socially, and technologically, highlighting the importance of developing sustainable, peaceful societies capable of managing powerful technologies responsibly. Moreover, this hypothesis challenges humanity to reflect deeply on our treatment of less advanced societies and ecosystems on Earth. Recognizing ourselves as the observed rather than the observers prompts valuable self-reflection, encouraging humans to reconsider their ethical obligations towards each other and towards Earth's environment. It pushes us to appreciate more fully the delicate balance required for a civilization's sustained development and survival. Ultimately, the prime directive hypothesis presents humanity with a profound philosophical and ethical perspective on our cosmic solitude. Rather than interpreting silence from the stars as evidence of emptiness or insignificance, it suggests a scenario rich with moral significance and responsibility. Perhaps the silence is not emptiness, but a purposeful choice made by wise observers, patiently awaiting humanity's ethical awakening and responsible evolution. As humanity continues to explore the universe, seeking signals of other intelligent life, the prime directive reminds us to approach this search with humility, wisdom, and respect. It invites us to contemplate the moral dimension of our cosmic isolation, envisioning a future where humanity's growth and maturity eventually merit participation in an interstellar community founded on mutual respect, ethical sophistication, and peaceful coexistence. Technological limitations hypothesis. The technological limitations hypothesis offers an insightful and pragmatic explanation for the profound silence humanity encounters when listening for intelligent life in the vastness of space. According to this theory, the lack of detectable contact or communication from extraterrestrial civilizations is not due to their absence or deliberate isolation, but rather due to fundamental technological and physical limitations that prevent effective interstellar communication or travel. This hypothesis emerges from considering the enormous distances separating stars and planetary systems within our galaxy. Even the nearest star systems are located several light-years away, with our closest stellar neighbor, Proxima Centauri, situated approximately 4 light-years from Earth. Such immense distances present daunting challenges for any form of travel or communication, fundamentally limited by known physical laws and technological constraints. One major limitation lies in the universal speed limit imposed by the speed of light. According to Einstein's theory of relativity, nothing can travel faster than the speed of light in a vacuum, approximately 299,792 kilometers per second. Consequently, even messages sent at the speed of light would require years or even centuries to reach distant stars. Practical interstellar conversations would therefore unfold over exceedingly long timescales, making meaningful dialogue challenging and potentially impossible. Moreover, achieving near light-speed travel, even theoretically, would require an extraordinary amount of energy and technological sophistication far beyond humanity's current or near-future capabilities. The closer a spacecraft approaches the speed of light, the greater its mass effectively becomes, requiring exponential increases in energy to continue accelerating. The physics governing these limitations suggests that interstellar travel might always remain prohibitively expensive, resource-intensive, and technologically daunting, even for civilizations far more advanced than ours. These challenges extend beyond propulsion systems to include issues of spacecraft longevity, structural integrity, and crew survival during journeys lasting potentially centuries or millennia. Any interstellar voyage must address prolonged exposure to cosmic radiation, micrometeorite impacts, and psychological stresses for potential travelers. The difficulty of maintaining technological systems and life support over immense time periods further compounds the obstacles to interstellar exploration and colonization. The technological limitations hypothesis thus argues that intelligent civilizations, regardless of their technological advancement, may ultimately find themselves confined by these universal physical and technological constraints. Even highly advanced species could conclude that interstellar travel and long-distance communication are impractical or economically unsustainable endeavors, opting instead to focus on improving conditions within their own planetary or local systems. This theory does not exclude the possibility that civilizations might still attempt interstellar communication, but it suggests that the signals might become too faint, diffuse, or distorted to detect clearly across vast distances. Radio and laser signals, commonly used in human attempts to communicate with potential extraterrestrial observers, weaken significantly as they travel through the immense interstellar medium. By the time such signals traverse dozens, hundreds, or even thousands of light years, they could dissipate into indistinguishable background noise, rendering them undetectable or indecipherable. Additionally, civilizations might employ vastly different communication technologies than humans anticipate. Earth's current search methods primarily focus on detecting radio signals or specific forms of electromagnetic radiation. However, more advanced civilizations might communicate using methods unknown or incomprehensible to humanity, such as neutrino beams, gravitational waves, or quantum entanglement, methods that we are currently unable to effectively detect or interpret. Supporters of this hypothesis also suggest that technological advancement might not progress infinitely. Civilizations might reach practical technological plateaus, beyond which further meaningful advancement is negligible or unnecessary for their survival and quality of life. They may instead turn their attention inward, focusing resources on sustainable living, virtual realities, or deep exploration of their home systems rather than seeking to overcome the profound difficulties associated with interstellar travel and communication. Critics of the technological limitations hypothesis argue that assuming universal constraints might underestimate future technological breakthroughs or new physical theories that could revolutionize travel and communication. Humans have historically overcome seemingly impossible technological barriers, such as flight, space exploration, and instantaneous global communication, prompting skeptics to contend that interstellar travel might also someday become achievable through currently unknown science and innovation. Despite these critiques, the technological limitations hypothesis remains compelling because it grounds discussions about extraterrestrial life firmly in established physics and practical engineering. Rather than assuming speculative scenarios involving hypothetical technologies or unknown physics, this hypothesis underscores the sobering reality of cosmic scales and universal physical laws. It challenges humanity to appreciate the profound complexities involved in interstellar endeavors, prompting deeper respect for the rarity and preciousness of our technological achievements. From a philosophical standpoint, this hypothesis offers a powerful reminder of humanity's place within the cosmos. It encourages reflection on the immense challenges inherent in exploring and understanding the universe, highlighting the necessity of stewardship and careful management of Earth's resources and technological capabilities. Recognizing these inherent technological constraints can foster a more thoughtful and sustainable approach to exploration, emphasizing quality of life and preservation over boundless expansion. Ultimately, the technological limitations hypothesis invites humanity to reconsider expectations regarding contact with extraterrestrial civilizations. Instead of viewing the cosmic silence as isolation or failure, This hypothesis presents a narrative of universal struggle against fundamental physical and technological constraints shared across civilizations throughout the galaxy. It suggests a universe filled with civilizations equally bound by the vastness of space, each navigating its own path within the limits imposed by the immutable laws of physics. In accepting these realities, humanity may find deeper appreciation and wonder in our unique yet universally constrained journey through the cosmos. Communication Gap Hypothesis. The communication gap hypothesis presents an intriguing and sophisticated explanation for the ongoing mystery of humanity's failure to detect or establish contact with extraterrestrial civilizations, despite decades of diligent search and observation. Unlike theories emphasizing intentional isolation or technological limitations, this hypothesis posits that the primary barrier preventing communication is rooted in fundamental differences in language, technology, perception, and even cognition between humans and extraterrestrial beings. At the core of this hypothesis lies the idea that even if intelligent life exists abundantly throughout the galaxy, these civilizations might employ methods of communication and technologies vastly different from those humans currently recognize or understand. Human searches for extraterrestrial intelligence primarily rely upon detecting signals within the electromagnetic spectrum, such as radio waves or laser pulses. However, other civilizations may communicate through entirely different physical mediums or methods unknown to humanity, rendering our current observational efforts ineffective or misdirected. The communication gap hypothesis suggests that extraterrestrial civilizations could utilize sophisticated communication methods involving neutrinos, gravitational waves, or quantum entanglement, methods that human technology is currently unable to detect or interpret meaningfully. These advanced forms of communication might offer superior privacy, efficiency, and speed, qualities highly valued by technologically mature civilizations. Consequently, humans might exist amidst a sea of interstellar dialogues without the tools or knowledge necessary to participate or even recognize their occurrence. Moreover, this hypothesis extends beyond mere technological disparity, proposing that fundamental differences in sensory perception, cognitive processes, and communication structures may exacerbate this gap. Extraterrestrial beings, having evolved under dramatically different environmental and evolutionary conditions, might experience reality through sensory modalities completely foreign to humans. They might perceive the universe through electromagnetic fields, chemical signaling, or vibrations outside human sensory capabilities. Consequently, their messages could exist in forms humans cannot sense or even conceptualize, further widening the communication gap. Additionally, linguistic and conceptual differences could form insurmountable barriers to meaningful contact. Human languages and forms of communication are deeply tied to our biology, cultural history, and environmental experiences. Extraterrestrial communication systems, shaped by unique evolutionary pressures, could operate on principles vastly different from those of human languages. Messages or signals might rely on symbolic systems or conceptual frameworks entirely alien to human cognition, making interpretation and comprehension nearly impossible without extensive mutual learning and adaptation. The hypothesis also acknowledges potential temporal misalignments as a significant barrier to successful communication. Civilizations separated by vast distances and developmental timelines might have evolved technologically and socially at very different rates, creating temporal gaps in which brief windows of opportunity for contact are easily missed. A civilization broadcasting messages across the galaxy could cease transmission or collapse long before humanity develops the technology required to detect and interpret these signals, resulting in perpetual missed connections and lost opportunities. Critics of the communication gap hypothesis often highlight the speculative nature of its claims, arguing that it rests on numerous untestable assumptions about the nature of alien life and communication methods. They contend that the hypothesis's broad claims make it difficult to establish empirical criteria for validation, potentially limiting its scientific utility. Despite these criticisms, Proponents argue that it offers essential insights into the complexity and nuance required for successful interstellar communication, emphasizing that successful detection and interpretation will require expansive and innovative approaches beyond traditional observational methods. This hypothesis profoundly impacts the ongoing search for extraterrestrial intelligence by encouraging broader, more diverse research strategies. It calls for interdisciplinary efforts combining astrophysics, linguistics, neuroscience, cognitive psychology, and computer science to explore and bridge potential communication gaps. Recognizing these communication barriers also motivates the development of novel detection technologies and methodologies capable of uncovering signals or phenomena currently beyond human understanding. From a philosophical and cultural perspective, the communication gap hypothesis highlights essential questions about the universality of intelligence, perception, and consciousness. It challenges humanity to reconsider deeply ingrained assumptions about the nature of intelligent life and communication. By acknowledging potential fundamental differences, humanity is prompted to approach the cosmos with humility, open-mindedness, and adaptability, fostering deeper self-awareness regarding the limits and potentials of our cognition and technology. Furthermore, this hypothesis implicitly emphasizes the value of diversity and the necessity of intercultural and interspecies empathy and understanding. Imagining encounters with fundamentally different intelligences pushes humans to appreciate and respect cognitive and communicative diversity within our species. This expanded perspective enriches humanity's understanding of communication itself, inspiring innovation and growth in human communication practices and technologies. Ultimately, the communication gap hypothesis provides a sophisticated and comprehensive explanation for humanity's cosmic solitude. Rather than suggesting emptiness or intentional isolation, it proposes a universe rich with diverse intelligences communicating in ways humans have yet to perceive or comprehend. By embracing the implications of this hypothesis, humanity is challenged to broaden its perspective, enhance its technological and intellectual capacities, and patiently seek understanding across the vast, mysterious communication gaps that separate civilizations throughout the cosmos. Timing hypothesis. The timing hypothesis offers a compelling explanation for humanity's enduring question regarding why, despite the immense scale and potential abundance of life in the universe, we have not encountered or detected clear evidence of other intelligent civilizations. According to this theory, the absence of contact arises primarily from temporal misalignment rather than spatial isolation or technological inadequacy. In other words, intelligent civilizations may have existed or may yet arise throughout the cosmos, but the vast differences in timing mean these civilizations rarely, if ever, overlap sufficiently to facilitate interaction or communication. At the heart of the timing hypothesis is an understanding of the enormous timescales involved in cosmic and biological evolution. The universe, estimated to be approximately 13.8 billion years old, provides a vast temporal canvas upon which countless civilizations could potentially rise and fall without ever coexisting. Intelligent life on Earth, by comparison, has existed for only a tiny fraction of cosmic history, a mere blink of an eye in astronomical terms. This fleeting presence highlights the improbability that humanity's brief period of technological advancement aligns neatly with those of other civilizations scattered across the galaxy. This hypothesis suggests that intelligent civilizations typically experience relatively brief windows of technological and communicative capability compared to the age of the universe. These windows might span only thousands or tens of thousands of years, minimal compared to cosmic timescales. As a result, the likelihood that multiple civilizations would simultaneously exist at comparable stages of technological advancement within communicative range becomes exceedingly small. A civilization that flourished 1,000,000 years ago would have vanished long before humanity's emergence, leaving behind no easily discernible traces detectable from our current technological vantage point. Furthermore, The timing hypothesis proposes that the rise and fall of intelligent civilizations might follow relatively predictable cycles driven by internal and external factors, such as environmental challenges, resource depletion, technological self-destruction, or evolutionary stagnation. Civilizations may be transient phenomena, briefly illuminating their corner of the galaxy before fading back into silence, leaving future civilizations unaware of their existence. Consequently, humanity might currently exist in a temporal gap, a quiet epoch in galactic history situated between previous waves of civilization and future emergences of intelligent life. Moreover, the hypothesis implies that signals from distant civilizations might have already passed Earth long before humanity possessed the technological capability to detect or interpret them. Ancient broadcasts or interstellar probes dispatched by civilizations millions of years ago could have traversed our solar system unnoticed, arriving at Earth during prehistoric eras or times before humanity developed the necessary technology. Conversely, signals sent from Earth today might reach other civilizations millions of years after humanity's extinction or transformation into a fundamentally different state. This temporal misalignment complicates humanity's search for extraterrestrial intelligence significantly. The vast distances of space, combined with the finite speed of electromagnetic waves and spacecraft, compound this problem further. Signals emitted by civilizations thousands or millions of light years away could arrive at Earth only after extraordinary periods, making timely and meaningful interaction impossible within human lifetimes or even human civilization's existence. Critics of the timing hypothesis argue that this explanation, while plausible, may underestimate the potential persistence or longevity of technologically mature civilizations. They suggest that advanced civilizations might overcome traditional limitations on lifespan and sustainability, possibly existing indefinitely through technological innovation, sustainable resource management, or expansion into virtual or artificial realities. These civilizations might thus maintain continuous communication or exploration capabilities over extended periods, increasing the likelihood of detection and interaction with others. Nevertheless, proponents counter that even if some civilizations achieve remarkable longevity, the sheer rarity of such success stories would still mean that overlapping existence with humanity remains statistically improbable. Additionally, the hypothesis encourages humility regarding humanity's temporal position, emphasizing the transient and delicate nature of civilization itself. It highlights the importance of careful stewardship of our civilization and planet, given the brief and precious window of existence that humanity currently occupies. From a philosophical standpoint, the timing hypothesis invites profound reflection on the fragility and ephemeral nature of intelligent life in the cosmos. Recognizing humanity's brief cosmic presence underscores the urgency and responsibility inherent in our civilization's current actions and choices. It emphasizes the importance of sustainability, peace, technological responsibility, and global cooperation, aiming to extend humanity's communicative and technological lifespan for as long as possible. Additionally, the timing hypothesis encourages expansive and patient perspectives in humanity's ongoing search for extraterrestrial intelligence. Rather than expecting immediate answers or discoveries, this hypothesis frames the search as an intergenerational and long-term endeavor, urging humanity to develop persistent monitoring technologies and strategies capable of detecting brief signals or fleeting phenomena occurring across immense temporal distances. Ultimately, the timing hypothesis reframes humanity's cosmic solitude not as evidence of isolation or insignificance, but rather as a reflection of universal temporal dynamics governing the rise, evolution, and eventual disappearance of intelligent civilizations throughout cosmic history. By embracing the deep temporal implications of this hypothesis, humanity can better appreciate its unique place within the unfolding cosmic narrative, finding greater meaning, responsibility, and wonder in the extraordinary circumstances of our brief yet precious existence amidst the vast expanse of cosmic time. Transcendence Hypothesis. The Transcendence Hypothesis provides a fascinating and thought-provoking perspective on humanity's ongoing quest to understand the apparent silence of the cosmos. According to this theory, intelligent civilizations, upon reaching a sufficiently advanced stage of development, undergo a profound transformation, transcending physical existence into forms that are either undetectable or incomprehensible to less advanced civilizations like humanity. This evolutionary leap beyond biological and physical constraints offers an explanation as to why, despite the potential vastness of intelligent life, humans have yet to encounter or detect extraterrestrial civilizations. Central to the Transcendence Hypothesis is the idea that advanced civilizations inevitably move toward an evolutionary point where physical existence, as humans understand it, becomes less desirable or necessary. Technological advancements in artificial intelligence, virtual reality, biotechnology, and quantum computing could eventually enable intelligent beings to upload consciousness into digital or other non-biological forms, existing purely as information, energy, or in other states that transcend physical matter. This transcendent state could free civilizations from physical constraints, including resource scarcity, environmental threats, and even mortality itself. In this transcendent condition, civilizations would no longer have the motivation or the need to communicate or interact through conventional means, such as radio signals or physical spacecraft, rendering them effectively invisible to humanity's current detection methods. The absence of traditional biological and technological signatures would naturally explain the persistent silence humans experience when observing the universe. Advanced civilizations might exist all around humanity, yet remain completely beyond our perception due to their fundamentally different nature. Moreover, the Transcendence Hypothesis suggests that civilizations reaching this stage of advancement might prioritize exploring inner spaces, such as virtual realities, enhanced states of consciousness, or abstract realms of mathematical or informational complexity. Rather than colonizing physical space or establishing interstellar communications networks, these civilizations could choose to immerse themselves in infinitely rich virtual or intellectual worlds, finding fulfillment and exploration within realms far beyond physical or conventional cosmic boundaries. The philosophical implications of this hypothesis are profound, challenging traditional notions of what constitutes intelligent life and its ultimate goals. It suggests a universal evolutionary pathway where material conquest and physical expansion are merely early developmental phases, eventually giving way to deeper, more sophisticated explorations of consciousness, meaning, and existence. This concept resonates deeply with humanity's own philosophical and spiritual traditions, which have long speculated about transcendence beyond physical existence as a higher or ultimate state of being. Critics of the Transcendence Hypothesis argue that it relies heavily on speculative and untestable assumptions about the future trajectory of technological and social evolution. They point out that the hypothesis depends significantly on extrapolations from current trends in technology and societal values, assuming universally shared goals and motivations among diverse extraterrestrial civilizations. Skeptics further contend that even highly advanced civilizations might retain an interest in physical exploration, resource acquisition, or interstellar communication driven by curiosity, survival instincts, or practical considerations. Nevertheless, advocates argue that transcendence could represent an evolutionary inevitability driven by universal incentives, such as the desire to overcome existential risks, physical vulnerabilities, or finite resources. Civilizations might view transcendence as the ultimate solution to these challenges, providing permanent stability and safety in an inherently uncertain and volatile cosmos. By transitioning to forms of existence not bound by biological needs or physical limitations, these civilizations would achieve unparalleled freedom and security, ensuring their survival and prosperity indefinitely. Additionally, proponents of the hypothesis suggest that humanity might already be witnessing early indicators of such a transcendence pathway through the rapid development of virtual reality technologies, artificial intelligence, and digital consciousness initiatives. The increasing integration of human lives with digital environments and the burgeoning exploration of artificial intelligence-driven realities hint at a trajectory that might eventually lead humanity toward its own form of transcendence. The Transcendence Hypothesis thus provides a powerful narrative that integrates technological forecasting with deep philosophical reflection. It invites humanity to contemplate not only our search for other intelligent life, but also our own evolutionary path and long-term destiny. By presenting a vision of advanced civilizations existing beyond physical detection, the hypothesis encourages humility, curiosity, and openness to forms of life and intelligence radically different from our current understanding. Ultimately, the Transcendence Hypothesis reframes humanity's cosmic solitude as neither isolation nor emptiness, but as an indicator of deeper, unseen complexities within the universe. It proposes that intelligent civilizations may be common, but exist in states so advanced and radically transformed that they elude human perception entirely. Embracing this perspective broadens humanity's search for meaning and understanding, expanding our conception of life's potential forms and ultimate goals. This hypothesis challenges humanity to explore new frontiers of consciousness, technology, and existential philosophy, urging us to reflect deeply on the nature of intelligence, purpose, and ultimate transcendence. It underscores the possibility that humanity's journey might someday lead beyond the stars, not through physical exploration alone, but through profound transformations of consciousness and existence itself, joining other civilizations in realms currently beyond our imagination and detection. Isolation Hypothesis. The isolation hypothesis, also known as cosmic solitude, provides a striking explanation for humanity's continuing silence in our quest to find intelligent extraterrestrial life. At its core, this hypothesis proposes that Earth might be uniquely isolated in a vast region of the universe, positioned far from other life-bearing worlds, making contact or detection extraordinarily improbable. Rather than attributing humanity's cosmic solitude to intentional isolation, technological barriers, or evolutionary outcomes, the isolation hypothesis emphasizes spatial distribution and astronomical conditions as the fundamental reasons behind the absence of extraterrestrial communication. Central to the isolation hypothesis is the concept that intelligent life, while perhaps not entirely unique to Earth, is extraordinarily rare. The universe, despite its immense size, might feature widely scattered pockets of habitability separated by vast expanses of barren, inhospitable space. Within this sparse distribution, Earth could find itself located within a particularly large and empty region, a cosmic desert lacking other civilizations or even basic biological life within a detectable range. The immense distances and sparse distribution of potential life-bearing worlds drastically reduce the probability of successful detection or interaction. According to this hypothesis, Earth's isolation could result from the complex interplay of astrophysical, geological, and biological factors necessary for life. Galactic regions with extreme conditions such as frequent supernova, radiation bursts, or volatile stellar activity could render large areas uninhabitable, significantly narrowing potential zones for life. Simultaneously, habitable worlds must meet strict criteria for stable climates, suitable atmospheres, protective magnetic fields, and geological activity, all conditions that are exceedingly difficult to satisfy simultaneously. Earth's position within the Milky Way galaxy itself illustrates this precise isolation. Our planet lies in what astronomers call the galactic habitable zone, an optimal region neither too close to the chaotic and dangerous galactic core nor too distant where essential elements for life are scarce. Even within this favorable region, the distribution of planets capable of supporting intelligent life may remain sparse enough to isolate Earth effectively from its nearest potentially inhabited neighbors by vast interstellar distances. Moreover, the isolation hypothesis underscores the rarity of the evolutionary processes required for intelligent life to emerge and thrive. The evolution of intelligence and complex societies depends not only on biological and environmental conditions, but also on extraordinary stability over immense periods. Geological evidence reveals that Earth's own evolutionary history involved numerous near-catastrophic events, mass extinctions, and significant climatic upheavals. The improbable survival and subsequent flourishing of complex life on Earth highlight how remarkably rare such outcomes might be across the galaxy. Critically, this hypothesis also emphasizes the vast timescales and distances involved in interstellar communication and exploration. Even if other civilizations have existed, the immense expanses of space separating stars and planets effectively isolate civilizations temporally as well as spatially. Signals or spacecraft traveling at or near the speed of light would require decades, centuries, or even millennia to traverse the vast distances between stars, rendering timely and practical communication extremely challenging or virtually impossible. Proponents of the isolation hypothesis argue that humanity's current observational efforts, although sophisticated, are still severely limited by technological constraints and the fundamental laws of physics. The signals humans can detect are extraordinarily faint, requiring precise alignment, timing, and sensitivity to capture. Given the vast empty spaces between potentially inhabited worlds, the chance alignment necessary for successful detection becomes astronomically improbable. Critics of the isolation hypothesis, however, often highlight the inherent uncertainty of assuming widespread cosmic emptiness. They argue that the observable universe contains billions of galaxies, each with billions of stars, increasing the statistical likelihood of abundant, intelligent life significantly. Critics contend that declaring widespread cosmic solitude may reflect humanity's limited observational capabilities or a premature conclusion drawn from insufficient evidence. Nonetheless, the isolation hypothesis continues to resonate deeply due to its philosophical implications. If humanity genuinely resides in a particularly isolated region of the universe, our position carries profound responsibilities and existential significance. It emphasizes the preciousness and fragility of intelligent life, underscoring the immense importance of preserving Earth's delicate ecological balance and ensuring humanity's long-term survival. Furthermore, cosmic isolation calls humanity to a deeper appreciation of our rare fortune in existing at all, prompting thoughtful stewardship and sustainability of our home planet. It encourages introspection about the value and purpose of human civilization, highlighting the ethical imperative to protect and nurture Earth's unique biosphere amidst an apparently silent and indifferent cosmos. Ultimately, the isolation hypothesis reframes humanity's perception of the universe and our place within it. Rather than viewing cosmic silence as evidence of insignificance or loneliness, this hypothesis presents isolation as a defining characteristic of our existential condition, a scenario that bestows upon humanity extraordinary opportunities and profound responsibilities. Recognizing ourselves as potentially rare and isolated stewards of life, intelligence, and consciousness prompts deeper reflection on humanity's purpose, potential, and ethical obligations. In embracing the isolation hypothesis, humanity can find inspiration for greater unity, sustainability, and cooperation, driven by the awareness of our unique position amidst a vast cosmic solitude. It invites us to approach the cosmos with a mixture of humility, reverence, and resolve, committed to exploring and understanding our extraordinary yet isolated existence within the grand tapestry of the universe. Quiet Universe Hypothesis. The Quiet Universe Hypothesis presents a compelling and contemplative explanation for humanity's continued inability to detect or communicate with extraterrestrial civilizations despite extensive observational efforts. According to this theory, the universe may indeed host numerous intelligent civilizations, yet these civilizations deliberately choose to minimize or completely avoid emitting detectable signals, adopting behaviors that render them effectively invisible to current human detection methods. Central to the Quiet Universe Hypothesis is the concept that advanced extraterrestrial civilizations have strategic reasons for intentionally minimizing their visibility. These reasons could stem from caution, self-preservation, or ethical considerations shaped by historical experiences, evolutionary pressures, or strategic foresight. Such civilizations may recognize that emitting detectable signals into the cosmos could pose significant risks, attracting unwanted attention from potentially hostile or competitive species. Consequently, silence and stealth become rational survival strategies in a vast and uncertain universe. Advocates of this hypothesis suggest that intelligent civilizations capable of interstellar communication or travel might have learned through experience or historical knowledge that broadcasting their existence invites potential threats. History on Earth illustrates this idea clearly. Encounters between different cultures have often led to conflict, exploitation, or catastrophic outcomes for less technologically advanced societies. Extrapolating this historical pattern to interstellar scales, civilizations might naturally conclude that caution and silence offer the best protection against unknown risks. Furthermore, the quiet universe hypothesis argues that advanced civilizations might employ sophisticated methods to minimize their cosmic footprint, making them exceptionally difficult or impossible to detect with current human technology. These civilizations could utilize highly directional communication methods, carefully aimed transmissions, and tightly controlled electromagnetic emissions, significantly reducing the likelihood of unintended detection. They might also operate primarily within shielded habitats, subterranean environments, or virtual realities, further limiting detectable signals escaping into space. Additionally, advanced extraterrestrial societies might adopt long-term observational strategies, silently monitoring developing civilizations from a distance without interference or contact. By maintaining quiet observation, these civilizations can gather detailed information, carefully assess potential threats or benefits, and make informed decisions regarding future interactions. Such deliberate invisibility aligns closely with concepts such as the zoo hypothesis or prime directive, reflecting ethical or strategic motivations to avoid prematurely influencing less developed civilizations. This hypothesis also explores the possibility that civilizations might universally gravitate toward internal exploration, virtual existence, or transcendent states, significantly reducing their interest in external exploration, communication, or colonization. A civilization advanced enough to harness vast energies or create sophisticated virtual realities might prioritize inward-facing endeavors, such as virtual worlds, artificial intelligence-driven environments, or transcendent consciousness, over physical exploration or interstellar communication. Consequently, these civilizations become quiet by default, focusing on activities imperceptible to outside observers. Critics of the quiet universe hypothesis often argue that deliberate universal silence seems improbable given the diversity and potential conflicts of interest among intelligent civilizations. Critics point out that maintaining complete silence or stealth across numerous civilizations over immense cosmic timescales would be challenging, with occasional leaks or accidental signals likely. They also suggest that curiosity, exploration instincts, or competitive behaviors might eventually override caution or strategic considerations, leading civilizations to broadcast detectable signals or actively explore interstellar spaces. Nevertheless, proponents of the hypothesis counter these critiques by emphasizing that highly advanced civilizations could develop exceptionally disciplined social, technological, or ethical frameworks capable of enforcing strict silence and minimal detectability. These societies might possess governance structures or cultural norms firmly dedicated to avoiding detection, driven by deeply ingrained historical lessons or existential risk assessments. Advanced technologies could further facilitate precise control over emissions and communications, enabling near-total invisibility to external detection. Philosophically, the quiet universe hypothesis invites profound reflection on humanity's behavior, technology, and ethical responsibilities regarding interstellar communication and exploration. It encourages caution and thoughtful consideration about the potential consequences of actively broadcasting humanity's existence into space. Recognizing silence as a possible strategic or ethical choice among intelligent civilizations underscores the importance of carefully evaluating humanity's own cosmic footprint and communication strategies, balancing curiosity and discovery with prudence and foresight. Moreover, this hypothesis deepens humanity's appreciation of the complexities inherent in potential interstellar relations, fostering greater humility, respect, and introspection regarding our place within the cosmos. By imagining the motivations and strategies underlying universal silence, humanity gains valuable insights into our societal vulnerabilities, ethical considerations, and strategic foresight necessary for responsible participation within a broader cosmic community. Ultimately, the quiet universe hypothesis reframes humanity's cosmic solitude not as evidence of emptiness or insignificance, but as an indication of careful, intentional, and strategic behavior by advanced civilizations across the universe. Rather than viewing the universe as barren or hostile, this hypothesis presents cosmic silence as a deliberate and potentially wise response to existential risks, uncertainty, and profound ethical considerations. Embracing the quiet universe hypothesis inspires humanity to approach interstellar exploration and communication with greater responsibility, ethical maturity, and strategic caution. It invites continued exploration, innovation, and philosophical contemplation, guided by a deeper understanding of potential cosmic behaviors and motivations. In doing so, humanity moves closer to potentially overcoming universal silence, readying ourselves to participate thoughtfully and responsibly within the broader tapestry of intelligent life across the universe. Thank you for joining us on this exploration of humanity's greatest cosmic mysteries. Each of these hypotheses challenges us to rethink our understanding of existence, our technological ambitions, and our responsibilities as custodians of life on Earth. Which theory resonates most with you? Share your thoughts in the comments below, and don't forget to subscribe for more explorations into the wonders and mysteries of our universe.